question 11.1.9, and we have some data on banana sales here, and we are looking at trying to see if there's a difference between the average number of pounds of bananas sold per week within a store if the display is placed in three different areas. So one being the produce area, one the milk area, one the cereal area. So I have my data in Excel already, and if you've seen the videos for the last couple of questions, I'll try to go through this one a little bit quicker. And first question is asking what's the null and the alternative hypotheses. So hopefully by now, doing a few of these, you've kind of got it down where the null is that the means are always equal, and the alternative is that the means are not equal, or that at least one of them is not equal in the group. All right, so we need to determine the F statistic as well as the p-value. So let's do the data analysis Toolpak here real quick. And we'll select our range. Labels selected, 0.05 alpha is what we're using. Output range A10 to start is fine. And this is what we come up with. So we come up with the F statistic of 2.32, matches the answer in the system here, and we have a p-value of 0.148, also matches what we have over here in the answer field. So we're good there. We have the F critical value if we needed to interpret that. And next question is asking, as far as the null goes, do we accept or reject? So we do not reject because the F score is less than, or the F test is less than the F critical score here. Also looking at the p-value approach, the p-value 0.15 almost is greater than alpha 0.05. So that's another reason why we would reject or not reject the null. So there's not sufficient evidence to conclude that there is a difference in the average number of pounds of bananas sold per week in these three locations. So next question is asking about multiple comparison tests. And being that we were unable to reject the null, we have to assume that the null is correct, that the differences are the same. So the difference in the average number of pounds of bananas sold per week, there really is not a difference between the three locations. So in this case, there's really no reason to do a comparison test. And so for these three, we're just answering that the multiple comparison test is not warranted. So this is a pretty easy question, but let's imagine we needed to use XLStat. Let's just show how we can get the same information in XLStat to give you a little bit more practice. And then let's go ahead and just run the Tukey-Kramer test anyway, just to see what the results look like. So what I will do is, again, for XLStat, I need to create another title here. We'll just call it bananas. And go up to our XLStat application, modeling data, and ANOVA. And this is kicking me back to the airport problem. So go back here to the bananas problem. And just select that whole area. And number of factors is 1, so one-way ANOVA. Output is going to be to a separate sheet. Options. Again, it likes to kick me back to there we go. So levels, we have 3 levels: produce, milk, and cereal. So we're good there. And if we go to output, analysis of variance, and then under means, we have the Tukey option there selected. So we should be good to go. And remember, F stat and our p-value from the data analysis Toolpak. We've got the answers over here as well, and you can see that they are the same. So as this loads here, we've got 2.32 as the F stat, and our p-value of 1.48 matches the data analysis Toolpak results. And just out of curiosity, let's see what the Tukey-Kramer results look like down here. We really didn't need to run this because we were not able to reject the null in the first place. But you can see quickly the significance comes back as no on all three, meaning that there is no difference. We are not able to reject the null, which would state in this case that the average number of pounds would be the same in each section. So be the same in the produce versus milk section, same versus produce versus cereal, same versus cereal versus milk in that case. So again, just didn't really need to run it in the first place, but just kind of another way to look at it, another confirmation of our initial results. And we can interpret it the same way with these three here as well. The standardized differences are less than the critical value, and the p-value is greater than alpha in all three as well.